Good morning, students. This morning, for MTH101, we'll be considering the topic titled Theory of Quadratic Equations. Now, from mathematical world, when we say an equation simply means mathematical statement that involves equality sign. Let's say, for example, we have A plus B equals C. If this equality sign is missing, this is just a mathematical expression. But depending on this equality sign, make this an equation. This is an equation, while ax plus b is just a mathematical expression. Now, when we say quadratic, we have been, from our secondary school, from a primary, secondary, we have been considering equations. When we say quadratic means the highest degree of that equation is 2. Now we have general quadratic equation to be a squared plus bx plus c equals 0. This is general quadratic equation where our a, b, and c are real numbers. They are real numbers. And our a must not be equal to 0, because if our a is 0, it simply means it's no longer quadratic. Now, looking at this, a squared plus bx plus c equals 0. At our stage, nobody will tell us to be solving a quadratic equation. But there are some things that will be examined under quadratic equation. Now, the first thing I'll be talking about is our discriminant d. Discriminant d. What do you mean by discriminant? We all know that if we solve ax squared plus c, a squared plus bx plus c equals 0, naturally we are going to have two solutions, because the number of the degree of the equation will determine the number of solutions we are going to have. If we are solving a linear equation, we are going to have just one solution. But if we are solving a quadratic equation, it is expected of us that we are obtaining two different solutions. Now, let's look at our discriminant. What is discriminant? If we solve quadratic equation, naturally we have our solution in form of x plus minus b plus minus b plus or minus square root of b squared minus 4ac all over 2a. Now, our discriminant d equals b squared minus 4ac. Our d is called the discriminants. Discriminants. Now, our discriminants naturally will tell us everything about that equation. It will tell us the nature of roots. There are so many things we are going to make use of about this discriminant d. And naturally, how do we obtain this? Our discriminant. I will take us back to what I believe we know in our secondary school days. We use quadratic community method to solve these quadratic equations. Now, let's title it solution of quadratic equations. Quadratic equations. using completing the square method. Completing the square. The square method. Now, we'll follow the principle line by line. Let's label our equation 1 to be ax squared plus bx plus c equals 0. Let's label this as our equation 1. The first thing we have to do here, based on the square method, is to divide through by the coefficient of x squared. Divide through by the coefficients of x squared. Last, when you look at this equation 1, for x squared, the coefficient is a. For x, the coefficient is b. While for our constant term, which is c, the coefficient is c itself. Divide through by the coefficient of x squared. We have a over a plus bx over a plus c over a equals 0. Looking at this, we have, because a cancels a, plus b over ax plus c over a equals 0. Now, the next thing for us to do is to subtract c over a from both sides. Now, class, subtracting c over a from both sides, right? Subtracting c over a from both sides. From both sides. Label it as equation 2. From both sides of equation 2. This will give us x squared plus b over ax plus c over a minus c over a equals c over a minus c over a. Subtracting c over a from both sides. This will give us x squared plus b over a plus equals minus c over a. Because looking at it, c over a minus c over a will give 0. Now, this produces equation 3. Now, the next thing for us to do is to add half of b over a to both sides, as squared to both sides. We have x squared plus b over a x plus half of b over a all squared equals minus c over a plus half of b over a all squared. You add half of b over a all squared to both sides of equation 3. And as you can see on the board, we have this. Now, what's the next thing for us to do? The next thing for us to do is to harmonize this side and resolve this side. This will give us x plus b over 2a all squared. We factorize it to be in this form. And this side will give us what you have minus c over a plus half of b over a all squared. Let's expand this. This will give us minus b over a plus b squared over 4a squared. The next thing was we should look for a way of merging this together by considering the LCM which we did in our primary school days. So we have x plus b over 2a all squared equals the LCM of this a and b is 4a squared. So this will be L of 4a squared, a in 4a squared. That will give us 4a. 4a times minus 2. This will give us minus 4ac. Then plus, now 4a squared is 4a squared. It will give us 1. So 1 times this square, this one will give us this square. Plus, when you look at this thing critically, if I have minus a plus b, I can write it as b minus a. It is mathematically true. So I can write minus 4ac plus b squared as b squared minus 4ac. So I will now write everything as x squared plus b over 2a all squared equals b squared minus 4ac everything over 4a squared. Now we have this. The next thing for me to do now is to take the square root of both sides. Taking the square roots of both sides. Taking the square roots of both sides. Let me label this as my equation 4 of equation 4. So this will be x plus b over 2a equals plus or minus square root of b squared minus 4ac all over 4a squared. Now, students, we all know that when you are taking the square root of a certain number, naturally it simply means you are going to have positive and negative, but that's what we have plus or minus square root of b squared minus 4ac over 4a squared. Plus, from the theory of sum, we all know that if I have root a over b, it simply means I can write as root a over root b. Note that square root of a over b can be written as root a over root b according to the principle of sum. Now, class, we are going to apply this principle on this my left hand side. Please label this as John 5. We apply the principle of sum, which we demonstrate here on this side. So this will be x. Sorry, to the x, not x squared. We have x plus b over 2a equals plus or minus square root of b squared minus 4ac over square root of 4a squared is allowed according to the principle of sum, which we have learned right from our secondary school. Now, looking at this, once I arrive at this, I find square root of 4 and then I find square root of 8 because naturally square root of 4 squared simply means root 4 times root 8 squared, which will give us x plus b over 2a equals plus or minus square root of b squared minus 4ac over 2a. Label this as equation 7. Now, looking at the result we have for question 7, subtract b over 2a from both sides. Subtract b over 2a from both sides of equation 7. This will be x plus b over 2a minus b over 2a equals plus or minus square root of b squared minus 4ac over 2a, then minus b over 2a. We can put this in front if we so desire. Looking at this, I will have this cancel this. I can write as x equals minus b over 2a plus or minus square root of b squared minus 4ac over 3a. Now, class, if we look at this critically, we will observe that on the right hand side, that is referring to equation 8, you observe that on the right hand side, you have minus b over 2a plus or minus square root of b squared minus 4ac over 2a. Since they are on the same LCM, I can simply put them on the same LCM so that they'll be together. So I will now have equals minus b plus or minus square root of b squared minus 4ac everything over 2a. Now, the result we have in equation 9 is what we call almighty formula or quadratic formula. In our secondary school days, we always call it almighty formula, but mathematically it is called quadratic formula. So we have it as x equals minus b plus or minus square root of b squared minus 4ac over 2a. Indirectly, we have two solutions for x because at the beginning, I said if you are solving a quadratic equation, you are going to have two different solutions. Now, looking at what we have here, we have x equals minus b plus or minus square root of b squared minus 4ac over 2a. It simply means one of the results is x equals minus b plus root x squared root b squared minus 4ac over 2a, and also minus b plus or minus minus root b squared 4ac over 2a. Note that our b squared minus 4ac is equal to d, which is our discriminant. And we said d is the discriminant. Our d is the discriminant. Now, I want to look at, let's consider the following examples. Consider the following examples. Obtain example 1. Obtain the discriminants of the following equations. Of the following equations. The first one is x squared, Roman figure 1, plus 5x plus 6 equals 0. Roman figure 2 is x squared minus 3x plus 9 equals 0. The third one is 2x squared minus 5x plus 7 equals 0. You can see the board clearly. Obtain the discriminant of the following equations. The first one is x squared plus 5x plus 6 equals 0. The second one is x squared minus 6x plus 9 equals 0. While the last one is 2x squared minus 5x plus 7 equals 0. Solution. Solution. The first one, x squared plus 5x plus 6 equals 0. Now, we are going to compare this equation with the general quadratic equation so that we can know what our A stands for, B stands for, and C stands for. Comparing this with the general quadratic equation, A plus BX plus C equals 0. It implies that my A is 1 because the coefficient of x squared is our A. Coefficient of x is B, while the constant term is C. So our A is 1, B is 5, and our C is 6. Now, class, we all know that discriminant D is B squared minus 4AC. Let's now compute so that we can obtain our discriminant. Now, our D will be, our B is 5, that's 5 squared minus 4 to bracket 1, then to bracket 6. Our 6 is 6. Looking at it, 5 squared is 25. Now, 4 times 1 times 6. 4 times 1 is 4. 4 times 6 is 24. Mathematically, our discriminant D is equal to 1 because 25 minus 1 minus 24 is 1. Now, other examples. Roman figure 2. Our x squared minus 6x plus 9 is equal to 0. Following the same principle, our A will be 1 because our A is the coefficient of x squared, while our B is negative 6. Our C, which is the constant term, is 9. So our discriminant D is B squared minus 4AC, which is D equals minus 6 all squared minus 4 into bracket. Our A is 1, our C is 9. So this is 36 minus 36. Class, our discriminant will now be 0 because 36 minus 36 will give us 0. Now, the last but not the least, which is 2x squared minus 5x plus 7 equals 0. Following the same principle, our A is the coefficient of x squared. Our B is negative 5, which is the coefficient of x. Our C is 7, that is the constant start. Now, our discriminant, which we all know to be b squared minus 4ac. Our d will be b is -5. We have -5 all squared minus 4 into brackets. A, our A is 2, while our C is 7. Now, looking at this, our D will be 25 minus 4 times 2 is 8. 8 times 7 will give us 56. And now, class, when you look at this physically, what is 25 minus 56? Mathematically, this will give us -31. Our D will be -31. Please, let's critically and copy everything down. Thank you. I will proceed. Now, class, having done this, we want to consider the relationship between the roots and the coefficients of the quadratic equations. Now, we must not forget that the solution of quadratic equations are also regarded as the roots of quadratic equations. When we talk about roots, we are talking about solutions. The roots of quadratic equations also provide the solution of that quadratic equation. Now, let's go ahead. Relationship between the roots and the coefficients of a quadratic equations. Now, when we are using computing square method to solve the quadratic equations, if you follow the principle step by step, you will observe that our x has two different solutions. We have x equals minus b plus root b squared 4ac all over 2a. I also have x to be minus b minus root b squared minus 4ac over 2a. Class, since we have two different solutions, we'll say let alpha and beta to represent the roots of the quadratic equation. Let alpha and beta be the roots of the quadratic equations. Ax plus bx plus p equals 0. Let's label this as equation 1. If alpha and beta are the roots of this equation, meant that instead of writing x equals minus b plus or minus 4c over 2a, we simply have alpha to represent one part, then beta to represent the other one. Now, if we have this equation 1, divide through by a, which should be, we now have plus b over a x plus c over a equals 0. Let's label this as equation 2. Now, if alpha and beta are the roots of this equation, if we recall from our secondary school and intermediate mathematics, we observe that in forming equations, we need to solve minus alpha into brackets minus beta equals 0. Label this as 3. Because since alpha and beta are the roots of the equation. Now, let's multiply. We have x squared minus x beta minus x alpha plus alpha beta equals 0. I will write it as x squared minus into brackets alpha plus beta all to x plus alpha beta equals 0. Label this as equation 4. Now, at this point, or at this junction, it is important for us to make some justification. When we look at equation 1, our equation says plus bx plus p equals 0, and equation 4 says x squared minus alpha plus beta or bracket x plus alpha beta is equal to 0. Now, we are going to compare equation 1 and equation 4. We are going to look at these two equations and make some deductions. Comparing equation 2 and 4. Comparing equation 2 and 4. We'll see that x is there and also here. The second term, we have plus b over a, and looking at equation 4, we have minus into bracket alpha plus beta into bracket x. Also, the constant we have plus b over a. In equation 4, we also have plus alpha over beta. Now, from here, it implies that our alpha plus beta, let's put that negative alpha plus beta equals b over a. I can write it as, but let's not by negative, I will have alpha plus beta equals negative b over a. Label that equation 5. Also, in terms of the constant term, you will observe that our alpha beta is equal to c over a. Label this as equation 6. Class, you can see that All these they follow based on the principle of formation of equation. And like equation 2 and equation 4, comparing them, we obtain equation 5 and equation 6. Equation 5 says alpha plus beta equals negative b over a. Also, our alpha beta equals c over a. Which simply means that in the formation of equation, we need the sum of roots and the product of roots. Sum of roots. Sum of roots, which is alpha plus beta equals negative b over a, and product of roots, which is alpha beta equals c over a. Mathematically, it can be stated that in the formation of quadratic equation, we have made up, if we are looking in terms of x, it will be x squared minus sum of roots into bracket x plus of roots, everything equals 0. This, let me label it as equation 7. This equation 7 is the general principle for the formation of quadratic equation, which is x squared minus sum of roots into bracket x plus product of roots, everything equals 0. Let's look at it sequentially so that we can have the full mastery of the concept. Let's write it fast so that we can go to the next context. Now, the next thing we'll consider is the nature of roots of quadratic equations. The nature of roots. Looking at a quadratic equation, without solving the equation, at this stage, we should be able to say the nature of roots. Nature of roots of a quadratic equations. Now, we all know that the roots of quadratic equation bx plus 3 equals 0 is given by the roots of the quadratic equation ax squared plus bx plus c equals 0 is given by x equals minus b plus or minus square root of b squared minus 4ac everything over 2a. Now, the discriminants, the value of discriminants will state categorically how the solution will look like. Now, we all know that the discriminant is d, which is b squared minus 4ac. I will categorize this into 4 cases. The case 1. Case 1. When our d equals b squared minus 4ac is equal to 0. When it is equal to 0, naturally, we are talking about equal roots. When b squared minus 4ac is equal to 0, it shows that the two roots will be real and equal. The two roots will be real and equal. The two roots will be real and equal. Example. Let's look at this example. When we have example, let's take this question down. Example, x squared plus 10x plus 25 equals 0. When we have x squared plus 10x plus 25 equals 0. Here, our A is 1, B is 10, C is 25. So our D will now be B squared minus 4AC, which should be 10 squared minus 0.1 to 25. Looking at this, our D will be 100 minus 100. So our D is 0. So when zero like this occur, it means the roots will be real and equal. The roots will be real and equal. Now the second case. Our case 2. Please, let's go fast. Our case 2. when D equals B squared minus 4AC is a perfect square. A perfect square. I know we all know the meaning of perfect square. That is a certain number when you take the square roots and you get a perfect number which is not a solid. For example, when we talk about 9, it's a perfect square. 16 is a perfect square. 25 is a perfect square. 121 is a perfect square. 100 perfect square, and so on and so forth. Such number, when you find the square roots, you obtain a rational number that is fixed, that is definite, not a solid. When D equals B equals is a perfect square, then the two roots will be real, and unequal. Will be real, unequal. Okay, let's say it's real, unequal, and rational roots. Rational roots. Real, unequal, that is distinct. You can put a bracket in front of the unequal, distinct. Real, unequal, and rational roots. A perfect example of this. Let's consider an example. Example. When we have x squared minus 10x minus 10 is equal to 0. X squared minus 7x minus 10 equals 0. Class, our A will be 1. Our B will be -7. And our C will be -10. Going back to our formula, that says D is equal to B squared minus 4AC. So our D will be, we have -7 all squared minus 4 into bracket 1 into bracket -10. So our D will be -7 all squared will be 49. Then -4 times -10. This will give us our negative, I'm sorry that the mix up here. This is supposed to be 3. Sorry. So we have -3 that will be 9 minus. So when we compute this, what are we going to have? We have 9 plus 4. So this will give us 49. The question is x squared minus 3x minus 10 equals 0. Our A is 1, B is -3, C is -10. Computing and discriminant D, which is B squared minus 4AC. Our B is -3. negative 3 squared will give us 9. Then minus 4 times a. Our a is 1, that's 4. Minus 4 times minus 10, that's plus 40. So 9 plus 40 will give us 49. So looking at this, since this one is a perfect square, since D is a perfect square, the two roots will be real, unequal. You can put in bracket these things, and rational roots. Let's go fast before we proceed to the next case. Now, case 3. Case 3. When b squared, case 3, sorry, when d equals b squared minus 4ac is greater than 0. When b squared minus 4ac is greater than 0, but not a perfect square. But not a perfect square. The two roots will be real, unequal. Now, we want to look at the third case. When b, that is our discriminant, which is greater than 0, this is positive, but it's not a perfect square. The two roots will be real, unequal, which I said to put in bracket distance. Then, and irrational. To be real, unequal, this thing, and irrational roots. Let's take this question now as an example on this example. Plus 5x minus 1 equals 0. Again, x squared minus plus 5x minus 1 equals 0. Now, our discriminant is b squared minus 4ac, where our a is 1, b is 5, and our c is negative 1. Let's compute. Our d will be 5 squared minus 4 into bracket 1 into bracket negative 1. So this will be 5 squared is 25. Negative 4 times 1. That's negative 4. Negative 4 times negative 1 is to give us plus 4. This is 29. It is positive. It is positive, and the roots will be real, distinct, and irrational. Again, the roots will be real, distinct, and irrational roots. The roots will be, because our 29 is positive, which is greater than 0, will be real, unequal, you put in bracket distance, and irrational roots. Now, please let's go back before we look at the last case on this. The fourth case, case 4. If we recall that for case 1, we said when b squared and 4ac is equal to 0, we are going to have real equal roots. When case 2, we said when the discriminants, that is, our b squared and 4ac is greater than 0, and also a perfect square, we are going to have real, unequal, and rational roots. But he still says when b, that's our discriminant, is greater than 0, but it's not a perfect square. The two roots will be real, unequal, and irrational roots. Now, the case 4 now, we want to look at the situation when discriminant b equals b squared and 4ac is less than 0. That is negative. Here, the root will not be real, but a complex. So the roots will be complex and unequal. That is distinct. Example. X squared plus 3x plus 4 is equal to 0. Again, x plus 3x plus 4 is equal to 0. Our discriminant is b squared minus 4 is here. Our a is 1, b is 3, c is 4. So our discriminant will be 3 squared minus 4 into bracket 1 into bracket 4. So which is 9 minus 16, which is negative 7. Our D is negative 7. So the root will be so the roots will be complex in nature and it will be unequal. The two roots will be complex and unequal. That is distinct roots. Please, let's study fast so that we can move to the next concept. Thank you. Are we done with this? Now, the next concept is to look at the formation of quadratic equations. Formation of quadratic equations whose roots are functions. Formation of quadratic equations whose roots are function of the roots of the given quadratic equations. That is, we want to form some quadratic equations whose roots are functions of the already given equations. Formation of quadratic equations whose roots are functions of the roots of a given quadratic equations. Now, let's look at this problem. Suppose, right? Suppose alpha and beta. Suppose alpha and beta are the roots of x squared minus 7x plus 10 equals 0. Form an equation. Form an equation whose roots are whose roots are 3 alpha plus 3 beta we have 3 alpha plus beta, sorry, and 3 beta plus alpha. The question again, suppose alpha and beta are the roots of x squared minus 7x plus 10 equals 0. Form an equation whose roots are 3 alpha plus beta and 3 beta plus alpha. Solution. The given equation is x squared plus minus 7x plus 10 equals 0. Now, let alpha and beta be the roots of x minus 7x plus 10 equals 0. Label this as equation 1. If alpha and beta are the roots of this, then alpha plus beta, which we all know that is minus b over a, will be minus, into bracket, minus 7, which is equal to 7. And also, our alpha beta, which is c over a, this will be 10 over 1, which is 10. 10 divided by 1, which is equal to 10. Now, we are forming another equation. We have to form another equation whose roots are 3 alpha plus beta and 3 beta plus alpha. The first thing we need to do here is that we look at the sum of the roots and the product of the roots. Now, sum of the roots. The sum of the roots will be 3 alpha plus beta, then plus 3 beta plus alpha. So this one will give us 3 alpha plus alpha, that's 4 alpha, then beta plus 3 beta. So will give us 4 beta. Now, product of roots will be 3 alpha plus beta times 3 beta plus alpha. So this will give us 3 alpha times 3 beta, that will be 9 alpha beta. 3 alpha times alpha, that will be plus 3 alpha squared. Now plus beta times 3 beta, that will be 3 beta squared. Then plus beta times alpha, we have alpha beta. Now 9 alpha beta plus alpha beta, that will give us 10 alpha beta. Then plus 3 into bracket alpha squared plus beta squared. Recall that alpha plus beta all squared is alpha squared plus 2 alpha beta plus beta squared. Our alpha plus beta all squared is alpha squared plus 2 alpha beta plus beta squared. Then we can write this as alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. Therefore, product of roots will be equals 10 alpha beta plus 3 into brackets alpha plus beta all squared minus 2 alpha beta. That's the product of roots. And from the principle of formation of equation for quadratic case, we all know that formation of equation of quadratic in terms of x will be ax squared plus bx plus equals 0, which is our quadratic equation. It will be the form x squared minus sum of roots times x plus the product of roots. It will be this x squared minus sum of roots to x plus products equals 0. Now, let's put our parameters and obtain our results one after the other. But for sum of roots, we have 4 alpha plus 4 beta. We can see that 4 is common. We have 4 into bracket alpha plus beta. From what we have done before, our sum, our alpha plus beta is 7. So we have this to 28, while the product of roots is 10 alpha beta plus 3 into brackets alpha plus beta all squared minus 2 alpha beta. So this will be 10 times our alpha beta is 10 plus 3 into brackets. Our alpha plus beta is 7. So this will give us 100 plus 3 into bracket. Our 7 squared is 49. 49 minus 2 times 10, that's 20. So this will be 100 plus 3 into bracket 49 minus 20, that will be 29. And what's now 3 times 29? That will give us 87. 100 plus 87. So we have 187. We have 187. Now, the required equation, the required equation will be of the form x squared minus sum of roots bracket x plus product of roots. Product of roots equals 0. So which will be x squared minus 28x plus 187 equals 0. This is the required equation for this problem we are solving. Please, let's write back. Exercise. Right. If alpha and beta, if alpha 1 and beta are the roots of three x squared minus 7x plus 2 equals 0. Find A alpha squared plus beta squared, B alpha over beta plus beta over alpha. Question 2. If alpha and beta are the roots of five x squared minus 7x minus 3 equals 0, form the equations whose roots are A alpha squared over beta squared, alpha squared over beta, and beta squared over alpha. B alpha minus 1 over beta and beta minus 1 over alpha. 3. If alpha and beta, if alpha and beta are the roots of x squared plus x minus 1 equals 0, form the equation whose roots are alpha plus 1 over beta plus 1 and beta plus 1 over alpha plus 1. Please, all these exercises are meant to be solved. They are very important. Thank you very much for listening. Okay.